much actually for having me here. I really would like to thank especially Asma for inviting me here. It's a pleasure. It's my first time to be in Tunis. So today you'll see me around, but tomorrow you'll be seeing me probably in the city. Okay, I'll be speaking about mobile cloud networking. I think, you know, my job has become a bit difficult because Adnan has spoken about many things which I was intending to speak about. Because this is really very much relevant to NFV, network function virtualization, as well as software-defined network. But the good news is that actually NFV and SDN, they are actually enabling technologies for mobile cloud networking. So I will show you the story, you know, how we can achieve, how we can build, you know, to start with the conclusion if you want, how we can build mobile networks over the cloud. So it's going to be like a piece of software. And this is quite very interesting. So this is the outline of my presentation. How many of you have heard of the evolved packet system? Can you please raise up your hands? EPS. All right. I see the distinguished speakers and a few. All right. So that's why actually I was expecting people not to be too much aware of EPS, and that's why I have actually going to make a brief introduction to the system. If you use 3G, if you use 4G, if you use even 2.5G, which is GPRS, actually you're using the system without even realizing that, okay? Because we as consumers, we just know iPhone, we know Samsung, but we don't know the core network which is actually giving us the connectivity so we can enjoy those services on those kind of devices, all right? I must admit, the first part is a little bit boring, okay? And that's why I'll try to go very quick on it because it's an introduction to a system which is already built. Okay, so there is nothing new. The second part, I promise that I will make it more interesting. So it's actually the future, and as you can see there, it's towards 5G. So we're going to build, or we're trying to work on the 5G system. Nobody knows what 5G is going to look like, but we're trying, and I will give you one perspective of 5G, okay? And cloud computing, NFV, SDN will play a very crucial role in this 5G system. Okay, if time allows, and actually I don't know how much time I'll be, for how much time I'll be talking. I think there is a coffee break in the middle. Anyway, if you feel bored, please raise up your hands and tell me stop, and then we can have a coffee break. So the last part is actually congestion. You're already bored? Okay, sorry. The last part is actually congestion management in 5G. Actually, the idea is how we can use cloud computing, how we can think beyond the traditional concept of congestion management schemes that we have already, you know, we use in existing systems by, you know, exploiting all the advances in NFV, SDN, cloud computing, and so on. We will, if time allows, we will touch upon that. All right, before getting into, you know, my talk, I would like to briefly introduce Aalto University. How many of you have heard of Aalto University? None. That's why actually I'm going to introduce it to you. Okay, Aalto University. It's a university in Finland. I hope everybody at least have heard of Finland, right? Okay, that's good news. I am actually from the School of Electrical Engineering. It is this university, it's in Finland. And Finland is well known for vodka, no, vodka, that's Russian. It's well known for, yes, exactly, so and it's also very famous for education. So I think you can see there, it's ranked top 3 for skills in science, mathematics, and reading. A salary of a teacher in primary school is much higher than the salary of a doctor. Just to have an idea that these guys, they give a lot of potential for education. Well, it's ranked 3rd best country in the world in prosperity by you know, a certain index. Aalto University is actually, it's a new and old university. It's a new university because it's just it was created in 2010, but it is actually old because it's a merge of very, very old universities. The three top ones: University of Art and Design, Helsinki School of Economics, Helsinki University of Technology. By the way, TKK, they call it the mother university of Nokia. So all the people working in Nokia, most of the people working in Nokia, he got their degrees from this Helsinki University of Technology. So it's very old. It started from 1849, but the merge happened in 2010-11. Okay, they have their mission. I mean, the mission of the university is to be world-class university by 2020. It has been actually ranked as #1 university in terms of startups creation. And it consists of many schools, but the thing which maybe you want to know, or I would like you to know, is that I'm from here, from School of Electrical Engineering. And I am from this department, Communication and Networking, which is very much collaborating with top companies like Ericsson, Nokia, and so on and so forth. Indeed, lots of cooperation is happening with many companies there. Aalto University is in what they call the Silicon Valley of Finland. Lots of SMEs, small, medium enterprises. It's very interesting because, that enables us at least, to interact with these companies and well-established companies as well as small, medium enterprises. Okay, research, it's really a research-based university, of course with some teaching. And it has this startup culture. So we have what we call the Aalto Entrepreneurship Society, and we have this Aalto Center for Entrepreneurship, and we have something which we call startup sauna. So if a student has a good idea, he can go defend it, and then there is like an incubation center which we call sauna, because by the way, Finland is well known for sauna. So sauna, it's the only term that you know as Finnish, and it comes actually from Finland. So there is a startup sauna, so students can create their own companies, and then they will have, all the financial support and so on, from the university and also from venture capitals. Focus areas of research are energy and environment, health and well-being, information communication technology, micro and nanotechnology, and I am, contributing somehow, probably all of us, to the ICT. So if you want to know more about Aalto, you can visit its website. So that was hopefully in brief about Aalto University. And now I would like to, oh, the weather, that's the bad part actually. Okay, so the weather is very cold. Days are very short in winter, but they are extremely long in summer, and don't come to spend Ramadan there. Okay, so as I promised it, because the whole concept of mobile cloud networking is about building a mobile network that has been so far static on very dedicated hardware. Now we want to build it as a piece of software on any cloud. Okay, and this is something which is really going to, it's a completely new concept. And you will see in my second session, the second presentation, it's a multi-billion-dollar business that lots of companies are very much interested in it, lots of stakeholders, even new ones are emerging. But before understanding why we're getting even to that level of building a mobile network on the cloud, we have to see, what has been happening in the architecture of the evolved packet system. Why we have even now 4G, and how does it look like in comparison to the previous systems? Okay. So I will go through, what happened, what kind of changes, and then I will get, into the main talk, or the main topic of today's presentation, where I'll speak about why we need cloud to build mobile networks on them so we can solve problems and challenges that we see. All right, so there are actually many standards bodies that have been contributing to the mobile telecommunication area. Okay, WiMAX, 3GPP2, TiSpan, and all of these somehow came from what I think Adlan mentioned earlier, ETSI. But the one which has been gaining a lot of ground is 3GPP. Okay, a third generation partnership project. Okay, and this is the standards body which has developed all the technologies that we are enjoying or we have been enjoying. GSM, GPRS, UMTS, LTE, and God knows what we're going to call 5G. All right, and so this is the one, the EU-TRAN. You don't have to worry about the abbreviations. I will explain to you the main ones that you have to memorize, mainly for those guys that are going to work in telecom, because this is the thing that you're really supposed to know. The system 3GPP, it has been very successful because in the standards itself, they've been thinking about how to build a system which is very much compatible with the previous systems, but at the same time, a system which will be interworking with other existing systems coming from different standards bodies. So that's actually the 3GPP thing, which is gaining lots of ground, as I said. Now, even in Europe, they start speaking about 5GPP. I don't know how many P's, 2 or 3. But anyway, they are 5GPP, but they are doing research. They're working on, basically research, which will lead to what we call, or what we are aiming for as 5G systems. So this is the structure of 3GPP. You have here a group which is working on somehow old system, GSM. Really, GSM, still I think we use it here in Tunisia, we use it in Morocco, we use it in many parts of the world. The only country which has turned it down, its last GSM switch was Japan, Docomo. They have turned it down just like a few months ago. So they have no more 2G because they have actually very global coverage of LTE. The other group is radio access network. So these guys, they've been working on really stuff which are actually relevant to the radio access network. And then we have here the system architecture. And my talk will be more relevant to the system architecture. So there is the radio access network, there is the core network, and then there is what we call the core network and terminal. But that's basically the protocols, how we can make those devices or these nodes communicate among themselves. So I've been actually assisting this working group, SA2, which is basically about the architecture, which is taking into account all the requirements which will come from the service providers or the operators, and then you take into account security, network management, and so on and so forth. It's really huge. What I want to say is it's a huge standards body with many people contributing to it. Just the SA2 group, which is a very subgroup of the whole thing, we were more than 250 people attending from different companies. All right, so 3GPP access evolution. I think many of you have heard of GSM, right? Yeah, at least you have used it. I mean, the ugly Nokia phones, they were actually for this 2G, so yeah. So, and then we are having, we have been seeing 2.5G, GPRS, and then 3G or UMTS. I think many people are using nowadays UMTS, and if you use any device now, I think you're using 3G. And if it doesn't work, you are falling back to 2.5G. And then beyond 3G, which is the LTE or LTE advanced. Okay, so this is actually the technology that we've been having. And these technologies, we've been seeing them because there has been always demand for more speed. Okay, because the interesting thing about the whole Lahouar telecom, that you build a system and you say, okay, this system is going to deploy for me or is going to accommodate this kind of services, and that's why you were aiming for certain, bandwidth like that. They started with 2 megabps, and then they said, no, this is not going to be enough, 14.4 megabps, then 28 megabps, and now LTE advanced, they say even 1 gigabps, but effectively you're not getting to that much. The thing is, you do you provide an access technology, and then lots of services will emerge, and then you realize this is not enough, and then you need more speed. So that has been the game. That has been actually the whole game. And you will see later that one of the important requirements of 5G, that they want to build a system which is going to support not only existing applications and services, but it has to anticipate, it has to forecast the demands and requirements of applications, say, in 10 years, so the system will be still working fine for the applications which we will see, 10 years, 15 years. And this is very challenging. Okay, lots of terms that we use. Long-term evolution. This is basically the evolved, the real term, the term that we use often is the evolved UMTS, radio access. Okay? EU-TRAN network, that's the radio network function. And then the evolved packet core. That's the thing that we don't see as users, we have never seen. You still can see the radio access network if you drive, you will see those antennas, those are actually the radio access network. But the core network, we don't see. I mean, companies produce and operators buy, but I mean, users don't see them. The other thing is, you may hear about evolved 3GPP system architecture evolution, but all of these are actually old terms. Now everybody knows the whole system as the evolved packet system. Okay? And the EPS, it is actually the radio access network plus the core network. The core network is called the EPC. All the other stuff, which are actually called 2G, 3G, 4G, 5G, those are actually not the real technical terms. Those are commercial naming of the service. Something which is very interesting, people they've been working on 4G, they've been working on LTE and LTE Advanced and even the previous technologies, and nobody could even call it 4G. So they had to wait till very 2010 when ITUT said, okay, LTE or LTE Advanced is going to be called 4G. Now, if we want to compare this with 5G, we already start calling something we don't know as 5G, but so we give the name in 5G just because we want to attract attention. The only convincing explanation of the system of 5G that I heard it actually from the very senior person from Docomo, and this guy said, whatever service we will be providing by 2020, we will call it 5G, even if it is the same system we have nowadays plus alpha and beta. Okay? All right, so now we will get, I hope in very brief, about the legacy 3GPP networks, and then, we will maybe, hopefully you'll enjoy the journey with me, seeing, how this system, what we've been adding to the system, till what we have nowadays as EPS. We will see the components, and then I will stop because this is a very long, somehow tutorial on EPC, and I will move to the 5G, which I said it's much more exciting. Okay, this is the architecture of GSM. And you can see it consists of, you have here the mobile station. Those are actually the very ugly phones that we had before. And you have here the radio access network, and you always have the core network which is connecting to, now we call it internet, but before it was called PSTN, ISDN, and so on. So basically, what I want you to know, for example, here we had two BTS, okay? Base transceiver station, which are somehow controlled by this base station controller. What you see, if you have, when you go outside and you see any GSM antenna, you're seeing only this. You're seeing only this. But this is going to be, it's hosted in the network by the operator. And even these links, most of the time, they are actually wireless. So they're actually microwave based. NEC produces some which are called Pasolink, and Tunisia is using those technologies. And then you have here, that's actually the radio access network. Now you have the core network. The core network was very simple in the beginning. It was consisting of this gateway mobile service switching controller, which is serving many mobile service switching controllers. All right? And then you have this home location register. That's basically when you go and you subscribe for the first time to an operator. You put your data and your profile, it's stored there. Okay? And this also keeps your location, where you are. If you go somewhere else, then your location is somehow kept in this visited alarm. The system is just based on circuit switch. Okay? And now we want to move to, of course, like there has been always this need for the packet switch technologies. Now let's see, if I want to make a call, I just call this guy. For example, I dial this number. The first thing it goes, wherever I am, it goes to my nearest GMSC. Okay? And then this guy doesn't know, this node doesn't know where I am. Then it has to, ask for the location from the HLR. And then if this person is somewhere else, is not at home, is not in the home public land, mobile network, it has to ask, where it is, contacting the VLR, and then, the routing information is sent, and basically, you build the switch, for that user, and the phone call happens. So these are actually the basic things about, GSM. Of course, the main service that they will use it is voice plus, the SMS. All right. Those are the features. But the circuit switch, as I said, it was okay because you have a circuit, which is dedicated for the user, so it's been okay for the voice communication, maintaining quality of service and so on. But because of that, the bit rate is very low. We're speaking about 14.4 kilobps. And that's why we wanted to move, or, at a certain point in time, we wanted to move to the packet switch, where you have the whole bandwidth shared, and then you send packets instead of having the whole circuit, dedicated to the users. So we want to move to a system that will give us higher bit rates, up to 170 kilobps, but which supports the packet switch services. And here we're speaking about the GPR. So what happened? So this is the architecture, okay? This is the architecture of GSM. One thing which is very interesting in the standards that you cannot come up, no matter how much requirement you have in mind, you cannot come and build a new system just like that, from scratch. You have to build it, and it has to be compliant to the previous systems. And that's why we are building on existing systems. So the GPRS architecture, basically what happened, we just added these two nodes, which are called SGSM and GGSM. Okay? So we can enable the packet switch service. All right. So for example, what happens, and then the GPRS protocol, the general packet rate, the GTP, this protocol of GTP, building tunnels between these two nodes, so we can send packets from here, or we can send them from there, and then they go all the way to here, and then they are like somehow tunneled. Okay? And in this way, what you are providing to the mobile station, you are just providing him with an IP address, which is called actually PDP, Packet Data Protocol Context, with an address, so this mobile station can use it for, packet switch communication. So that was actually the GPRS. So what we have added in the system, we added to the GSM, we have added these two nodes. Of course, we had to do some kind of software upgrade at these BSC, so they can deal with packet data, and then we send them to this core network. Now, that was not enough, and that's why we had gone to the UMTS architecture. In the UMTS architecture, we wanted actually to have that tunneling not only ending up here, but ending up, up to the radio access network, because the quality of service is the main business of mobile operators. So you want to have quality of service really ensured from, at least from the radio access network up to the last point or the last gateway, which is connecting to the internet or to the PSDN. All right, so that's actually the tunnel. So you can see that what we have added here in UMTS is basically building on the GPRS, we have added this. So now, even we don't call the mobile station as a mobile station, because we call it user equipment, and this user equipment has even a different software which is dealing with the node beats, via this dedicated interface which is called UU. And there are other interfaces which have been added. The other thing which is very interesting, that before we were using a very old protocol which is called SS7, Signaling Protocol, and now everything was built based on IP or ATM, because ATM somehow can guarantee for you some quality of service. In the release 5, basically, of UMTS, then they added the IP multimedia subsystem. Okay? This IMS, when it was created with the intention that the mobile operators will be having control on the services. Okay? And it's a really very complicated system and very expensive. So they wanted to have services basically in the mobile operators network, and then those services, they will be provided to the user equipment, to the users. In addition to their subscription fee, they had to pay some additional money or for the application. But now, because of iPhone, since people, they can just download applications and use them as at ease without any control, this one is not really gaining too much interest, at least for the general services. For the voice over LTE, probably it makes lots of sense to have it. Okay, so that was actually the UMTS. It's basically, if you're using 3G with your phone, this is the system that you are using. And still this system, the thing which was actually with this system, if you're using any service, nowadays, even with your phone, any service which is packet switch based, any service which is actually on the internet, it's using this system here. If you make any phone call, your phone call goes actually on the circuit switch, which is the old one, JSON. Now, one of the requirements of the LTE or of the evolved packet system, or of what they call the system architecture evolution, that they want to build everything on IP. Everything has to be IP. And this is what has been leading us to the system architecture evolution, or what we call as the evolved packet system. Okay, for the sake of time, I have to skip certain details here. But these are actually the requirements. And these are really important requirements. The first one is always on. Because before, the system the system has been designed in a way that you need to be, if you want to connect to any service, you have to ask for that, so you become on demand, and then you connect to the service, and then you start enjoying it. Once you stop the service, then you go off. Okay? But then in EPS, they said, no, we want this person to be always having an IP address. That means always on. And then the all IP network, I have already spoken about that. That means the whole system has to be PS or IP based. We will see, for example, in the second presentation, that the cost, reducing the cost, has been always the main factor in deciding, the system architecture for any mobile operator, because it's all about economy, how you can make more revenues, and reduce, the investment into your infrastructure. And then system with improved capacity and coverage. This is always, the concept that we want to have more capacity, more data rate, and this is also still a requirement on 5G and so on. The other thing which has been actually really, which happened in the evolved packet system, that the level of security has increased a lot in EPS, and I expect it to increase also in the context of 5G. So all of this have led to many releases of standards till the release of 8 of 3GPP, which, there we had actually the first, the first specifications of the system, which we call nowadays as EPS. Maybe this is a little bit of detail, but just to give you an idea that actually deciding an architecture, maybe, when I explain to you the architecture, you think it's just like a number of boxes you add here and there. But it's much more bigger than that, because you take into account lots of issues and concerns. For example, when they had to decide which architecture to go for, they were like these two architectures on the table. So this first one, architecture A, so basically you have the evolved packet core, which is the new architecture. You have it actually interworking with all the existing or with the future radio access technologies. The other view was, no, we will make something from scratch, which is fully dedicated for this new architecture, and then we will see somehow how we can interwork it, with the previous ones. And each architecture has pros and cons, has advantages and disadvantages. And nobody actually, there were like companies pushing for this, other companies that were actually pushing for the other architecture. But in the end, what we are seeing as the EPS that I'll be introducing, it's actually a merge of the two. Okay. So this is basically the evolved packet system for 3GPP accesses. Okay? One thing which I really like about this EPS, that it is actually designed in a way that you have the user data plane is separated from the control plane. Okay? And there is a reason for that. So if you have anything happening, for example, at the control plane, still, the user data plane will not be interrupted. And if you have anything which is happening, at the user data plane, it can be recovered quickly by the control plane. So, okay. There are some, I mean, this is really why I presented this, this introduction to the evolved packet system, because this is very much relevant. You know, you need this kind of understanding so we can speak about the mobile cloud networking, about the NFV, the network function virtualization, and how we can build these actually mobile networks on the cloud. So the first thing that probably you need to know is this packet data network gateway. Okay? So this is the one, when you connect to the network, this is the one which gives you, this is the one which gives you the IP address. Okay? So this IP address will stay with you as long as you have services coming, you know, through this gateway. And this is what we call as data anchoring gateway. Okay? So, one question probably to everybody so I can have your attention, because I see many people losing their interest. If I have a service, say that I am watching a YouTube video, okay? And this YouTube video, then I am here in Tunis and I'm watching it, and then probably I drive somewhere too far, and then I have another packet data network which is optimal for me because it's very close. Can I get an IP address on that packet data network gateway, the new one, and then have my service, you know, coming through there? No or yes? How many of you vote yes? How many of you say no? Okay, the people that say no, why? Can you explain? Come on guys, can I have your attention please? Yeah. That's indeed. Actually what will happen, because once you get your IP address here, then you know the server that is serving you that service doesn't know about the new packet data network, because it will keep on sending you the flow, I mean the packet of videos, but everything will come to here, and then this has to forward it, you know, using this tunnel to wherever you are. One thing which probably you should understand, that a user equipment can have multiple IP addresses if I have multiple PDN gateways. So as a user equipment, I can have multiple IP addresses. For example, one IP address which will serve my emails if I connect to my email network, another IP address which is going to be used, for example, for my company network, and another IP address which is for the internet. If you do your setting, for example, if you set up the system of iPhone or wherever, you always see APN. How many of you have seen this abbreviation which is called APN? You've seen it, okay. So the APN is called the access point name. So that means which service you're going to use and which gateway that service has to be taken from. That's actually the access point name. So anyway, what I want you to know, that the packet data network gateway is the place where your data is really anchored for that service, but you can have new services launched on other packet data network gateway. The one which is the node which deals with your mobility. So wherever you go, of course you move as user equipment and you keep on changing the node bits. You connect to new radio access network nodes. Okay? This is the node which keeps your flow or the traffic, the flow of your traffic coming through, and then this is the node which will take into account your new location, your new radio access network, and then your flow will be moved there. And that's why we call it the mobility anchor gateway. All right? So, one rule about the evolved packet system, as I said, you can have multiple PDN gateways, but you will never have multiple serving gateways. You'll be having only one single serving gateway. Okay? The other node which is very interesting or very important in the context of the EPS, it's called actually PCRF, which stands for Policy and Charging Rules Function. Basically, operators, most of the operators, what they do, they buy all of these equipments which are actually standards compliant from vendors, and the only thing that they play with somehow is the PCRF, because that's where they decide the policy, that where they decide how much, you know, they have to charge for certain, you know, usage. For example, you know, all of these different tariffs that you have. This is the node that decide, and this node, once it decides those kind of policies or those kind of charging mechanisms, he will send them to the PDN gateway, the serving gateway, and somehow you will enforce them, so you will be charged according to the tariff that was offered to you. Okay. Of course, like, if you are at your home network, you're connecting to the packet data network gateway. If you go somewhere else, for example, like I have my phone which is in Finland, if I use any data which is, from Finland, it will be coming via my PDN gateway which is in Finland, but still it will be served by the serving gateway which is here in Tunis. And why this? Why we need standards? Actually, the most important thing about standards is that if I am a user of an operator in a certain country, I come here, I still can use the system, or my phone will still understand the language of the nodes, which are actually in the visiting operator network system. All right. As I said earlier, there has been always this interworking with the previous system or backward compatibility. This is something which has been very important, and it's an important requirement for all the existing systems. And that's why, even in the context of the EPS, we have built a system which interwork even with the previous UMTS network, which is actually by the, where you can see here as SGSN. One thing else, all of the radio access technologies that have been developed by 3GPP, we call them as 3GPP accesses. And handover between them, somehow it's much easier than handovering from a 3GPP access to a non-3GPP access. Now, one question to you guys. A non-3GPP access, can you give me one example of non-3GPP access which we use very often? Wi-Fi. That's exactly one of them. And the other one? WiMAX. Exactly. So anything which is not developed by 3GPP, it's called actually a non-3GPP access. The interesting thing of EPS, the Evolved Packet System, as I said earlier, that it's a system which has been built to accommodate all the existing 3GPP accesses in addition to non-3GPP accesses. And even in non-3GPP accesses, there are actually two types. Okay? There are two types of 3GPP accesses. The one which are called trusted 3GPP non-3GPP accesses, and the ones which are actually called non-3GPP non-trusted or untrusted accesses. And I will show you via a very simple example how a decision on an architecture can really change the whole business of telecom. And I'll give you the example very soon. All right. So I think I will skip this, but I have already mentioned, the roles of packet data network gateway, the serving gateway, the MEMEs, and yeah, the mobility management entity. This is really something which I have missed, but the mobility management entity, please see it as the brain of the whole network. And it's actually the node which receives lots of signaling if you want to connect to the network. You know how it happens? The first thing that you do, you will connect to, of course, the radio access network, but it is up to this mobility management entity, by discussing with the HSS, with the home subscriber system, whether you're allowed to connect and not, and if you're allowed to connect, how much quality of service you're entitled for, and so on and so forth. So it's in charge of everything, the attach, detach, all of these procedures that are required for the mobile network. Something which is very interesting about EPS in comparison with the previous system, GSM or UMTS or GPRS. And this is one important requirement actually on the system, and that's why it has been designed in this way. That the architecture of the radio access network is flattened. So instead of having that radio network controller, like in UMTS, now we have only the E-node Bs, one E-node B, which is, only one node in the whole radio access network. And even you allow some kind of interfacing between the E-node bits. And this actually simplifies a lot the handoff management. So you can, it's basically the source E-node B, the source radio access network, which handles which target E-node B, which node you have to, hand off to. Okay, so there are many reference points, there are many interfaces, and every interface has a, has a role, but I can't cover all of them for the sake of time. this is actually one example, or the two options of how you can interwork, or how you can make the system interworking with the previous system. So, but basically, you can have the GGSN, you map it on the serving gateway, or you map it on the PDN gateway, and it's really up to the operator to adopt the variant which is easier for them to choose. Now, as I said earlier, we have the 3GPP accesses, which is any system developed by the 3GPP standards body. But the other ones, which are actually not 3GPP accesses, we said that we have two variants, the trusted non 3GPP accesses. To connect to the system, you need to have this access gateway. Okay? And there are also the untrusted non 3GPP accesses, which have to connect to the system via a node or a box which we call the EPDG, Evolved Packet Data Gateway. Now, I don't know if I have it in this slide. Now, something which is very important, that untrusted non-3GPP accesses, they cannot, any user equipment which is using, for example, WiMAX, cannot connect to the system unless he does all of the authentication with the system, with the EPS, and then once that AAA is granted, then he connected the network. Now the question to you guys, which one do you think is expensive to deploy? This one or this one? I give you one tip. This is very expensive box. And this is basically, it's just a simple software which you can build even by yourself. So which one becomes very expensive to connect to? This one or this one? Untrusted. This is actually the example that I want to give you to tell you that by choosing, by making a decision, you can kill a business, and so another business will remain active. So if you remember till 2005 and 2006, lots of people were speaking about WiMAX as being the main technology or the technology of the future. Okay, some people even they were saying WiMAX is going to become 4G, right? Now, WiMAX, and actually I believe that WiMAX is really much more fruitful, or it has much more advantages in comparison to the LTE. Why? Because we have one single access point of WiMAX which can cover the whole city, right? If you want to cover the whole city, how many eNode Bs you will be in need of? Well, at least more than one, multiple, okay? So if you do the math, I can buy one WiMAX network, one WiMAX access point, say, I don't know exactly the figure, but say €1 million, okay? And then the whole city can be served, the internet. So it's only investment of €1 million. And if I connect it to the network, then it should be working because it's still, it works to the system. Now, if I want to deploy cover or to provide coverage, in the whole city, probably I will be in need of minimum 20 eNode Bs. Those are eNode Bs, new ones, if I want to provide LTE. Each eNode B, it's still expensive. Even if you do the math, even if we assume it's €200,000, 200 times by 20, it becomes €2 million, right? So, if we go in this direction, definitely the eNode Bs or the LTE technology will die because it's more expensive than one WiMAX. Now to save themselves, 3GPP to save themselves, they said, we're going to qualify this WiMAX as a non-3GPP access because it is non-3GPP, but as untrusted, and to connect to the system, you have to buy this one which will be costing €2 million. So if you want, as an operator, if you want to use WiMAX, still you have to make an investment of €1 million plus €2 million, which is €3 million. Don't do that. Buy the eNode Bs from us. This is a decision, it's a very political decision that they had to take so they can favor one business over another business. Just to show you that actually the choice on an architecture, don't see this as just like one box and one line connected. It's much bigger than that. All right, so I think, I think I will just speak about these two next slides and then I will move to the next presentation, which I hope it will be more interesting. Okay. Now one question to you guys. When you want to connect to the network, in your opinion, how do you connect to that network? How does it happen? Can anybody explain to me how the attach procedure happens in this? Anybody knows how the attach procedure works? Hey guys, don't worry. I mean, you can say yes or no. Don't worry. If you answer, I'm not going to tell you explain because I can explain it. So how many of you know how the attach procedure works? Okay, one. Then now you can explain. No, I'm just kidding. All right. So I mean, this is the thing. Seriously, I want to present this. Although this tutorial is very long, so we could cover the quality of service, the policy charging, service differentiation, lots of things which have been happening in the EPS. But for the sake of time, I will stop after the explanation of this new transmission attach. So the first thing, once you are actually when you turn on your mobile phone, automatically this message is sent to the nearest e-node B that you detect. Of course, there is like some kind of physical procedures. The e-node B which has the strongest signal, you will connect to that e-node B and you will send an attach request. But that's it. This e-node B does not know whether you're allowed to connect to the network or not. And that's why this e-node B will just forward this attach request to the mobility management entity. And this is the main brain of the network. I will just, probably we will see that in the next presentation. Now, if you have an application which is misbehaving, an application, think of it, an application which goes off, and because of that, your mobile phone will just go off, because you can, as user equipment, you can still disconnect, you initiate the disconnection, and then you ask for reconnect. Now, think of an application which disconnects all the user equipment at the same time and ask all at the same time the network to reattach to the network. That means from all of these user equipment, thousands of attach requests will go to the new or to the single MME. And no matter how powerful that mobility management entity is, it will be limited in the number of signaling it can handle per second. And because of that, if you send, I don't know, maybe 100,000 or 200,000, the MME will shut down. And this really happened. This really happened, and I will show you in the next slide, how that happens. So that's why actually when we have these too many services running on the user equipment, and some of them they are created by application developers which are not aware of how the telecom network works, it can hurt. And that's why no matter what you're going to do, either you work in IT or in telecom, it's always advisable to you guys, if you want to develop any mobile application, to understand how the mobile network works, so you can avoid issues that you may create to the mobile network. And you don't know, probably the operator can even block your service. So once that attach request is sent, of course all of this is not relevant because these are actually, if you change the mobility management entity, basically what happens, okay, I think, yeah, it's actually this step. If you're attaching for the first time, the MME needs to authenticate with you, and it will consult the HSS whether you are allowed to connect to the network or not. Once you are allowed to connect, then the MME will give you this attach accept, but before even giving you the attach accept, it's the mobility management entity that will decide for you which serving gateway to select for you, and even which packet data network gateway to select for you. And there are also some logic in that decision. The logic is what kind of service you're going to ask for, whether it's very close to you or not, if you're like favoring like the geographically closer serving gateway or not. There are lots of metrics that can be taken into account to decide for single user equipment which serving gateway and which PDN gateway to select. Once those are selected, the MME will send a create session request to the serving gateway, and this serving gateway will send a create create session requests to the packet data network gateway. Now, one thing that you should understand, that there is no communication between the mobility management entity, no direct communication between this MME and the packet data network gateway, because everything, okay? Yeah, so there is no direct communication between MME and the packet data network gateway. Everything has to go via the serving gateway. Now, my question is to you guys, and I have already answered, or I have given hint, why MME cannot connect to the packet data network gateway directly? Can you please tell why? Okay, I'll give you hint number one, that we said a user equipment can have multiple IP addresses from multiple PDN gateways, but one S gateway. Now, how can you have that control that the user equipment will be having only one single gateway, unless you limit yourself to only one single S gateway? So that's actually the logic behind not having MME connecting to, directly communicating to multiple PDN gateways. All right, so once that session is created, then all of these procedures are happening, at the radio access network till the attach is complete. And once this is complete, that means you get your new IP address, and then you start enjoying the service. If you want, for example, you have an IP address, and this is what we were supposed to cover in the next, many slides, but I will skip that. If I am using, for example, a service, say YouTube, and in the beginning I watched a very low quality video, so I didn't need like too much bandwidth, but then I needed more bandwidth. Then what I can do, I will ask the network, or the network can do that even for me. I will ask him to give me a new bearer, and this new bearer, that means give me more bandwidth, because a bearer is actually how much quality, how much how much bandwidth, how much quality of service that I have to guarantee for you within that tunnel. But anyway, we don't want to talk about that because it's not really important for the understanding of the next presentation. Okay, if I can have a cup of water, that would be excellent. Appreciate it. Okay, so are we going to have a coffee break now, or I have to continue? I don't know. What's the problem? Asma is not here. Okay. All right. Anyway, so I will just continue. Huh? Yeah, this is the second. We can take coffee break. Yeah, we can take questions. I'm sorry, because I don't know. I was supposed to speak for 3 hours, but now I don't know when is the coffee break. I can receive questions about the first part, the evolved packet system. If you have any questions, feel free to ask. If none, then I would like to move on to the next presentation. But this presentation is actually consisting of two. This virtual programmable mobile networks, but also the congestion management. But as I said, I'm not sure about time, because time is, I don't know about the schedule.
Yeah, we still have to.
We go for coffee break, or I can continue? Continue?
We'll continue.
Continue. Can I have a cup of water, please? Okay, excellent. So then anyway, I think I should move on. Oh yeah, please. By the way, you can ask me, feel free to ask me questions even within the presentation, so no problems with that.
I have a question regarding the WiMAX use and the comparison between WiMAX and RT network. So you said that it's less expensive, if I understood well, that it's less expensive to use one WiMAX base station than 10 or more LB. You said that it's more expensive, isn't it,
Yes.
to place the ELB, the LTE ELB, but I didn't understand why finally they choose the use of ELB. And I think that there is a problem of interoperability between the WiMAX network and the third generation network. It's more easier to have interoperability between equipment
So, but I want to add, maybe I want to clarify this much further. As I said, like one single WiMAX access point will be enough to cover the whole city, right? And its cost is much less than the cost of multiple NOBs connecting, covering the same geographic area. Till this, we agree. Now the problem is, if you want to build your own WiMAX network as it is, I mean, you can do so, but who's going to use your system? Because people will be having user equipment, and you don't want to, for example, even if you have WiMAX here in Tunisia, still, as a Tunisian, you want to go abroad and you want to use the same phone, the same with another operator which is in France, but which is using actually 3GPP network. So somehow, even if you want to build your WiMAX network, you have to make it compatible with the existing or with the previous systems. In order to do so, you have to buy that box which we call the EPDG. When you buy it, the whole equation of cost becomes much higher to use WiMAX. So you have either, I would use, meaning you cannot use WiMAX alone, you have to use WiMAX plus EPDG as one set. If you take this as one set, and you compare it to the price of multiple NOBs, then this becomes more expensive, and automatically you just go for the LTE.
In addition, there is a problem of OpEx if you keep both networks apart.
Yeah, and that's why actually many people are not using WiMAX. I mean, WiMAX is used a little bit in Far East Asia, like I think Laos and Vietnam. Now there are actually, I could not cover that, but there are some operators, they think, many, they are using Wi-Fi to offload network. Okay? For example, if I have, we will see that probably in this presentation. If I have many services, people using YouTube, and they are like somehow, bothering my mobile network, then I just want to get rid of them by telling them use Wi-Fi for this, or just offload, get your stuff out of my network. So there are operators that are using Wi-Fi, that's the majority of them, but there is, at least as far as I know, there is one operator, at least as far as I know, which is using WiMAX for offloading. And that's actually KDDI. Okay, so, all right, so, yeah, thank you very much. It's very difficult to speak for 3 hours. Oh, yeah. Okay, so I hope that you understood, at least by now, you understand the EPS. Okay? The EPS is the Evolved Packet System, which consists or which refer to both the radio access network and the Evolved Packet Core. One thing which you should understand, that these nodes that we have in the EPC, they are actually built on very dedicated hardware. That means that's why you go to those kind of companies like Huawei, NEC, ZTE, and so on, Alcatel, Lucent, Ericsson, and you buy from them boxes which are, for that, specific gateway, PDN gateway, serving gateway. So they were like really built on dedicated hardware. As Adnan spoke about NFV today, the concept is we want to get, the software of those dedicated hardware or dedicated gateways. We want to get the software and we want to have it as a piece of software that we can use or we can run on any instantiated virtual machine anywhere in the world. That's the concept. So we can gain lots of things which are actually flexibility, elasticity, and so on and so forth. And I will explain that. Now, and this is exactly what I mean by this title, towards 5G. Carrier-grade, programmable virtual mobile networks. Now, just to explain to you guys, virtual mobile networks means that you are building a mobile network on the cloud. It's a virtual one, it's not a real one. Now, programmable means I can decide the way I want it to be. So I can decide, for example, today, I have a big event, I can place a network function here because I have a concert. So I build a network for that concert, tomorrow I release everything, and then I will run the same infrastructure, which is the same cloud, for a new thing. Okay? And this has to be programmable, automatic. I don't want even to be involved as a human being. It has to be done by itself. Now, carrier grade, this is something which is very important. Because, you know, the main thing, or the main business, or the main specifications of mobile operators, they have what we call the 5-9 reliability. That means the system is 99.999 reliable. It should not get down. And this comes even by regulators. I mean, like, that's why if you have, do you know, like, for example, Tunisia, which one? Tunis Telecom? Yeah. So Tunis Telecom, probably they have equipment from Huawei or from any operator, from any vendor. And that's why when you have a vendor, you always have some people working for that company being in that country. Do you know why? Because those guys, they sell equipment and they're supposed to maintain them, and they have a contract with the operator that their equipment or the system should not get down for more than, I don't know, maybe 1 hour the whole year. So if it is less, if it is more than 1 hour, there is a big fine on them. So that's what we mean by carrier grade. Now, as I said, this is relevant to the cloud, this is relevant to software engineering, and this is relevant to the telecom. It's very much, you know, so it's, you know, we're trying to build a system where we're going to join efforts from different areas that have been actually working separately, okay, towards a big vision, which is 5G. The other thing is that we are building a system which is supposed to be very reliable on a system which is the cloud, which does not guarantee for your reliability. And this is the main challenge. How many of you have had that blue screen when you use your PC one day and then you get the blue screen? Here is one. I lost even my data once. So you have your laptop and you get blue screen. Now imagine what can happen if you have a network function, a very important network, on a VM somewhere in the world. That blue screen can happen anytime. So you're not having reliability, but still you have to build the system which is reliable on a system which does not guarantee that for you. How you can do it, we will see. All right, so I have spoken, and that was actually the intention of my earlier presentation, how we have seen this 1G, 2G, 3G, 4G. Don't tell me that you're not using one of these technologies. We are so much dependent on them. All right? So hopefully I have explained how we got from here, GSM, to here, to here, and to here. Okay? Now, and yeah, I said like all of us were using this because there is a global LTE commitment. So people that have been working on WiMAX, I'm sorry for you guys. You know, I did also some work, but it was not very significant. So there is like, this LTE is deployed all over the world. I'm sorry, I see Morocco and Tunisia still planning, so let's see when this is. Do you already have 4G in Tunis? No. Anyway, the good news that actually it's blue, that means it's planning, so it's going to come. That's Morocco as well. Okay, but now, even before having a wide deployment of 4G, we already start speaking about 5G. Okay? A lot of research happening on 5G in the States, in Japan, China, Korea, and Europe. Okay? And these are just a few examples of projects. Recently, many projects have been accepted, approved, and also many of others have been rejected. Yeah, on 5G PP. Okay. Now the question is, what will 5G look like? That's a legitimate question. If anybody comes to you guys now and he says 5G is this and that, he's just lying, or maybe he's just a little bit narrow-minded. That means he's just seeing things from his own angle. Okay? As I said earlier, the only explanation which was convincing to me, I heard it from Docomo, he said, the service we will be launching by 2020, we call it 5G, even if it's 4G. We don't care, because we want to attract more customers. This is the latest exercise that has been done by the European Commission. 5G, as I said, we don't know how it's going to look like, but we know the requirements. We know 5G has to be this and that. Always we start with the requirements and then we see how we're going to meet it. So they tried actually to map the requirements to some of the projects that are running or maybe going to be funded. I was actually involved in this one, and Adnan spoke about it, or referred to it, mobile cloud network. Okay? So many of the things which I will be speaking about today here is somehow the outcome of some of the research work which was conducted in MCM. Okay, now, something which is very interesting to know about 5G, this was the requirement on LTE. I mean, these technologies, IMT 2000, IMT Advanced, and the future IMT, which is 5G, this is the requirement. What I want to say with this picture, which is not mine, by the way, this is the European Commission one, which has made this. So you can see that the requirement becomes much more bigger, or much more significant in comparison to the previous systems. Okay? So we want to build a system with much more challenging requirements. Something which I am very interested about, and I think I spoke about that earlier. This is also a slide which I got from Ericsson. So 5G is more than just bigger and better mobile broadband, because we've been always, as I have shown you earlier, there has been some changes to the architecture, but always there has been this demand for more and more speed. Okay, and that's why we've been seeing, you know, CDMA, OFDMA, and so on and so forth. But the thing which is interesting about 5G, it's going to be a platform on which any wireless application can be implemented. So you're not building a system which will support Facebook, Foursquare, YouTube, and you name it, but you are supposed to build a system which will accommodate future applications. Why is it the case, as we will see later? Because 4G has been designed under certain assumptions which do not work now well for existing applications. So they said we have to learn from the mistakes we have made before. I mean, we have to make a system which is very much, let's call it almighty. Okay? Well, I don't think. It's very challenging, but this is a very important requirement. Requirements on 5G. So high data rates everywhere, very high traffic capacity. This has been classical requirements for everybody, you know, for all the previous systems. Now, very low latency. And this is a very important requirement. The other day, I think Adnan also he attended this talk that was given by a senior from Microsoft. He was showing that if you have a mobile game, if you play in a mobile game, this game of guns, you know, this is a question to you guys, so you got to be careful to this, all right? So he said that if you have the user and you have the game stored in the cloud, okay, and the guy is playing this game, and if you have latency of 80 milliseconds, the computer is always winning. Do you know why? You shouldn't answer. Do you know why? Come on, guys. I think that you are all of you intelligent and you know the answer. It's very easy. The game is about shooting. You play and you shoot because there is somebody who's shooting you, in the computer. If there is 80 milliseconds, do you know what's 80 milliseconds? It's really nothing. If you have 80 millisecond latency between the user and the server that is hosting the game, the computer wins you quickly. And then the game becomes very boring because it doesn't work. Do you know why? Because by the time you're clicking on your shoot, the guy has already killed you. So it becomes very boring. The message that he was delivering was actually this latency, because now, as I said earlier, 5G is all about future applications, future services. And we will see what kind of future services. Future services like Google Glasses, although they have frozen the product, but still it will come. This augmented reality, mobile gaming. So if you build a system where people cannot enjoy the service, that service will die as well as the technology itself. And that's why in one of the Ericsson white paper, they say the latency they are aiming for is 1 millisecond. How can you do that? We don't know. But it's 1 millisecond in 5G. It's not yet regulated, but that's the aim, 1 millisecond. So that talk that was given by Microsoft guy, he said 80 milliseconds, the game becomes very boring because the computer wins. 30 milliseconds, you still start, killing the guy, and the game can start, can last for 2 minutes, 3 minutes. Okay. So what I want to say is latency is very important. Massive number of devices. 5G, one of the main business that they are actually building 5G for is MTC. Do you know what MTC stands for? MTC stands for? All right, you don't know. That's what I'm going to tell you. Machine type communication. It's very easy. Do you know M2M? All right. So M2M, Internet of Things. Do you know what's Internet of? Yeah. So Internet of Things, M2M, those are sensors. When you have that sensor with the SIM card, which connects to the network, we call it MTC device, machine type communication device. All right? So now we're speaking about a system which has to connect not millions of users, but billions of MTC devices that have to connect to the network. And that's why you need a system which will, which has to accommodate all of these large number of devices. I cannot recall where, but I've read somewhere, they are saying that we are expecting, even in 4G, three times of control traffic, that the control traffic will be 3 times bigger than the user data traffic. You know how much user data we have nowadays? It's huge, okay? YouTube, Facebook, and so on. Now, control traffic will be 3 times bigger. So, the congestion that we've been having in the user data plane, we will be seeing it in the control plane, and we have been actually seeing that. Okay, very low device cost and very low device energy consumption. Those are actually stuff that user equipment vendors like Samsung, iPhone, and so on, they have to worry about. Ultra high reliability, and this is something which is very important. That means you cannot just come and tell me that the system I am going to build is going to be on the cloud, and cloud does not guarantee for me reliability, so please can you tell me, is it okay if I build a system which is not very reliable? No, it is no compromise to make about reliability. Work it out somehow, and we will see how we can do it. Now, there are many key technology areas for 5G. As I said, at least this is, hear it, but then forget it later. I see 5G as a system which will integrate a bunch of technologies which will meet one or multiple requirements, okay? And cloud computing will play a major role there. NFV, SDN, I will repeat myself, are key enablers, and we will see if we make this system together, integrated in an efficient way, we can do good things. Now, the design goals of 5G, of course, scalability. We're speaking about number of phones that will increase because we'll be having multiple smartphones, and also many more applications, because many applications spanning on a very large ecosystem. And much more application and devices to serve in 5G systems. Okay? So this is what I was trying to communicate here, that we will see in 5G more and more services, more and more devices, diverse types of devices. And to understand how this is going to impact the system, or how challenging this is going to be on the system, we have to see what's going on nowadays in 4G or 3G or in between. And that's why we have to see the current landscape of 4G, mobile communications. All right. I really mean the title of this slide, smartphones racing ahead of mobile networks, because smartphones really are designed in a way that they just eat the bandwidth of the mobile networks. And more services. Recall what I have said earlier about IMS. IMS was designed so the operators can have control of the applications. The control is lost. Anybody can develop any crazy application, put it on iTunes, people will enjoy using it, and that will add traffic to the mobile operator. And that's what I mean by smartphones racing ahead of mobile networks. Growing business of tablets, same story. Because of this, the user equipment has changed, the concept of user equipment. In the earlier presentation, I showed you that the architecture has been evolved, and that's why we keep on calling it evolved packet system. All right? Even the concept of user equipment has changed. Now, in the context of 3G, or at least how the system, when people, they were designing it, how they were foreseeing user equipment, they were thinking user equipment will be smartphone, but not as smart as we have nowadays. And something which is very interesting, that they were assuming that this user equipment, they will be in two states, idle and active. Even if always on is a requirement of EPS, but still go sleep. You have your IP address, but sleep. Don't bother me. You just keep. You have an IP address. Whenever you need it, you can use it. So that was the assumption, and the assumption is that actually 90% of the time you are sleeping. Not you guys, the user equipment. All right, and then indoor. So when you go home, you connect to Wi-Fi. When you go to a mall, you connect to Wi-Fi. When you're outside, of course, there is no connectivity part of the mobile operator. You connect to that mobile operator. Now, what happened? In 4G and beyond, things have changed. A user equipment is no longer restricted to a mobile phone. It can be this laptop, if I have an LTE modem. All right? So if I have an LTE modem connected to this, I am supposed to enjoy all the services that I enjoy nowadays when I connect to a fixed network while being connected to the mobile network. User equipment is also M2M, or machine-type communication device. So we're speaking about not hundreds, not millions, billions. The other thing which is very interesting, now I'll ask you a question before telling you that. How many of you charges their mobile phones every day? Raise up your hands. How many of you charge that twice a day? You see, I think you guys, you have lots of applications on your mobile phone. Even if you don't use those applications, there is a lot of background traffic happening so you can keep the session alive. I tried this myself, you can do it by yourselves as well. Take your phone, okay? Turn off Wi-Fi, be sure that you're connected to the mobile network, all right? And turn on your laptop, desktop, and have Gmail application on your mobile phone and have Gmail on your laptop. You will see that actually the email updates that you get on your mobile phone are a bit faster than the updates that you get on your laptop. Why? That means that lots of traffic is happening, so the session has to be updated, alive, so you can keep updates, very fast. So that's why this is actually, if you want to gain a little bit of energy, if you want to increase the lifetime of your battery, of your user equipment, turn off those applications or just get rid of them unless you use them. With Facebook, it becomes even much worse because the updates happening a lot. So because of this, this is changing the whole concept from being 90% sleeping to being almost always active. Okay? And this is the basic assumption which has changed the whole thing. So it's a really very simple assumption, but it has, a big impact, on the stuff, on the mobile operating network. How many of you have heard femto? Can you raise up your hands? Small cells. Do you know what small cell and femto, what's the difference? Is there any difference? No, it's the same. Just small cell is actually the right naming of femto. Femto was some time ago, they were called femto.
In fact, it's femto as operator is used firstly for voice, but now for small cells in general for the name femto is used mainly for 2G and 3G for voice, to provide voice in.
As far as I know, that femto from the beginning, they were thinking actually you go home and you still connect to the mobile macro network, whatever service you're doing, including voice. But the name has changed because they changed the name of the standards body. Now, before it was called femto forum, now it's called small cell forum, and that's why they said we changed the name as well. So, in 3GPP, or at least in telecom, names keep changing a lot. And that's why sometimes even me, I have lots of difficulty to tell what this abbreviation, I know what it is, but I don't know what it stands for. So I understand if you have any difficulties with my presentation earlier, that issue I had as well. So anyway, what I want to say is, with femto, or with small cell, you go home, you go to mall, you go to train station, and if you're connecting to that femto, you're still connecting to the mobile macro network. That means the coverage area of the mobile operator has extended from being only outdoor to also include indoor. So all of these are, things which have changed the concept of user equipment, and all of this have led to what we call the mobile IP tsunami. Okay? Now, how many of you have you ever seen this slide, by the way, guys? Yes? When? Was it last year or just a few minutes ago?
Just a few minutes.
Okay, so excellent. So exactly, so that's why actually I tried to introduce to you the EPS. Okay? Do you know what this is called? Okay? I can give you water if you say the answer. Because I don't have other drinks. Okay, so that's actually the control plane. I mean, I've said that. And the user data plane. And I have explained to you why we have this logic of separating the control plane and the user data plane. Now, the thing which Adlan spoke about, that actually that control plane, when you want to have it automated by a central gateway, by central controller, then, that's actually what SDN, it becomes much more interesting. Anyway, because of these two types, or these two planes of the EPS, we can think of two types of the tsunami. The one which is hitting the user data plane, and the other one which is hitting the control plane. By the way, Asma, whenever you feel like having a coffee break, please tell me, so we can freeze the presentation and then I continue later. Because I'm not keeping really time.
Continue with the presentation until 4 o'clock.
Until 4, okay, that's good. But can you bear with me,
We will
guys?
take a coffee break just before Azure workshop.
Okay. All right. So maybe if you feel like having coffee, do we have coffee? You can go and come and. Yeah. All right. So the mobile data tsunami, the user data tsunami, of course. We know that mobile multimedia streaming. So let's see what's going on in terms of tsunami, which is hitting the user data plane. I mean, we can all of us agree that mobile multimedia streaming is something which will eat the bandwidth of user data plane. Now this is taken really from the latest statistics that you can have on the official website of YouTube. These say that every day people watch hundreds of millions of hours on YouTube and generate billions of views. The thing which I want you to pay more attention to, half of YouTube views are on mobile devices. Personally, since I started using my smartphone, I enjoy watching YouTube on my mobile phone rather than on even my laptop. I think, maybe people do the same. And there are more content providers entering into the mobile market because everybody wants to have a share, piece of this big cake of mobile market. Now, I also mean the title of this presentation, which is Small Applications Causing Operators Big Headache. How many of you have heard of Foursquare? Okay? Can you explain to the... All right. So Foursquare, it's actually a location-based social network. It's a damp application, but people are using it. Basically what you do, you can build a social network which is relevant to the location where you are. Like for example, I am in Tunis. I build a social network here, and then I send messages to people here, and they say the weather is nice. This is interesting for the people receiving that message, but for the operator it makes no sense. It brings no money. And I really did this experiment that you can do by yourself, just with my PC print screen. So I got in less than 10 seconds 5 more entries. And you can see here that each entry is a picture plus text. That means multimedia content. And why I call it small application, because the amount of traffic which is generated by one single user is very small. But when you see how many people are receiving it, how many people responding to it, how many people are creating, that mass of, traffic, it becomes, it creates what I call here as a big headache to operators. Now the thing is, when you have one guy successful in building an application like this, other people start doing the same thing. And the problem becomes much more significant. Of course, like Twitter, Facebook, classes, and so on and so on. Okay? And just speaking of Facebook, as of its latest statistic, you can see here that there are 1.9 billion mobile active users. So that mobile active users. And this is increasing 26% year over year. So people are using the message, many people, a huge number of people, using Facebook while being on the move. That means while connected to the network. Have you ever heard of Google Glasses?
Yeah.
Yes. Have you ever watched the promotion video of Google Glasses? It's very awesome, yeah? So with Google Glasses, if you see that product, it's really, I mean, they have frozen it. They have actually, you know, the product is frozen, but it doesn't mean that it will stop. At least, you know, Microsoft, they have the same thing, which is called HoloLens. They froze it because the market is not there yet. They froze it because people raise concerns about privacy. But what's privacy nowadays will not be privacy in 5 years or 10 years for my son, for example, or for, you know, people will be open to these kind of technologies and there will be a market for it. Now, with this Google Glasses, what you can do, you can walk and do the Foursquare application, that means location-based services. You can walk and take a picture and send it on the move to your cloud. You can do video conferencing. You can take a video and stream it to people. So you can imagine what you can do as a single user with one Google Glass and what kind of traffic you will be contributing to the network. Huge amount of traffic. And here I would like you to remind one thing, that the requirement on 5G, that actually the system has to be built for also future applications, future devices. So that means even if we don't have Google Glasses nowadays, we expect them to be there in 10 years. And that's why the system has to be built in a way that it will accommodate this kind of devices, augmented reality devices. So, and remember, I'm just speaking about what we are seeing nowadays in 4G. What we will see in 5 years, I don't know. It will be even much more significant. Now, to enjoy any kind of service on your mobile network, as I said earlier, there is a lot of signal and traffic which is being exchanged. And this is copy and paste from the specifications. I have spoken to you guys about the attach request, I have mentioned. But there are, you know, to connect to the network, there are lots of boxes that have to be involved, many signal and traffic that have to be transmitted or exchanged so you can enjoy that service. And this is, you know, as user equipment, you are here, but all the other nodes, you can see HGSN, S gateway, PDM gateway, you know, for different things, you know, for different procedures, for the mobility management, while being on the move, for quality of service, policy control, charging, gateway selection, function, load balancing. And that's why when people forecast 3 times of control traffic bigger than the user data plane, there is a reason for that. Mainly for the MTC, machine type communication, when you have a sensor that has to be on to send one message, which is temperature is 20 degrees or 50 degrees or I don't know, and then for that message to be transferred, all of this stuff have to be happening. Although you can treat the MTC sensor as a low priority, but still it is a user equipment from the perspective of the mobile operator. You know, if you think that this is, you know, this tsunami cannot happen, it did happen. And it happened to the most sophisticated operator on earth, which is Docomo. It's the #1 Japanese operator in Japan, because of the misbehavior of one application. There was one application, you know, the guy was making millions of it, you know, of money out of it, but this application was not designed in a way which is friendly to the mobile operators, so it was synchronizing at almost the same time. And there was a time when, you know, the mobility management entity just went down. And once the MME is down, then the whole thing, you know, can get impacted. Okay, machine type communication, as I said earlier, you know, to handle those user equipment, you have to do the same procedures that I have shown earlier. So, no doubt that all of this is leading to what we call the mobile IP scenario. Now, the question is, what do operators do about this? Okay? I mean, you can always say, I don't care, I will invest in speed. That means I will buy more equipment, I will buy more stuff, you know. But that means you have to invest money. All right? Upgrade network nodes. That means also you have to invest money. Design a scalable network. That means also, by the way, you know, the mobile network nowadays is planned for the peak hours. Do you know what peak hour? That means I can say that in the middle, not in the middle of the night, but during the prime time, there is this number of people that will make phone calls, and that's why I expect this much bandwidth, so you can plan the radio access network accordingly. Now, as I said earlier, in the context of the user equipment, in the context of 4G, when you have to provide all of these mobile services on the core network, can you really even, can you tell what's the peak hour? I mean, if you can, please be my guest. But there is none. I mean, there is always the peak hour. And all of this, even if you want to do this, even if you're so much rich as an operator and you're ready to, to invest, you still have to invest lots of money, and this will increase the cost. Now, the question is, will operators invest more? As far as I know, many operators, they are really, really trying to reduce, maybe you have mentioned the OPEX as well as the CAPEX, the money that you invest in the infrastructure itself. Why? Because many mobile operators, they have this flat data rate billing model. I recall when I was in Japan, I was happy to pay almost $150 for my subscription of the mobile phone. For that time, it was CDMA 1. But that was in 2000, 2001. Okay? Now, if you ask me to pay the same amount of money for LTE, I will say, sorry, I'm not going to pay that amount of money. Okay? And actually, this O2, which is Telefonica, it's operating in Spain, but it's all, operating all over, I think, Europe, even in Latin America. So they were advertising for LTE for 25 euros. 25 euros. I don't know how much you charge here for 3G, but these guys were charging 25 euro per subscription for LTE. Now, if you remember, when I showed you the architecture of evolved packet system, to deploy LTE, you still have to buy many eNodeBs. You have to buy, this new equipment, PDN gateway serving. That means you have to invest lots of money in the core, and yet you're not getting much revenue from the users. And that's why the operators, they've been dealing with this issue actually. That you have the traffic increasing and the average revenue per user is getting down. Okay? So it's more economical than technological, because from the technology point of view, if you have a problem, scalability, just upgrade your stuff and that's it. But you cannot do that because you will be running out of business. Now what the operators they've been doing some tricks. This is also something which I got recently about AT&T. AT&T is one of the largest mobile operator in the state. So what they do, if they see you using too much YouTube traffic, they will just either they will just get block you, and you will keep trying and trying, and you will see that stalking of YouTube, and then you give up. Okay? And actually they say we'll do it and we don't care. T-Mobile, which is an operator in Germany, it's also testing traffic blocking in peak hours in the Netherlands. Verizon is not only throttling, this traffic, but also transcoding. That means if I see you watching YouTube, then if I still have a little of bandwidth, then I will just I will transcode the video so you get it at reduced rate. And they do that for all over-the-top applications. Now, the answer to these guys, you get to be careful because you may lose customers. Okay? This is an example of a guy who was using LTE in Germany, and he was not happy with the service. So he's a student. He called the customer service center and they told him, well, sorry, you are just a single case. He found out, because nowadays it's not only the phones that are becoming smart, people also are very smart, with the usage of this. So he found out that actually it's not only him, maybe through Facebook, maybe through direct communication with his friends, that his friends also using LTE of Auto, they were receiving the same answer, you're just a single case. So he just made a blog, which he called We Are Single Case, which is very bad for the reputation of the company. Okay. So now, let's look at the problem. Problem you have on the application level, because of the IMS that is lost from your control as an operator, you have more applications appearing and you cannot do much about it. You cannot control it. From the physical point of view, you have this dilemma that you have to deal with, which is reduced cost per bit. So that's why, you can't do much here and there. Operators, they started saying, okay, let's look at the platform. What can we do at the platform? By the way, one of the things one of the big assumptions based on which, one of the characteristics of mobile operator networks, that they are centralized nowadays. I don't know about here in Tunis. Say that you are, what's the farthest city from here? Huh? Sidi Bouzid, okay, let's say Sidi Bouzid. Okay, you are in Sidi Bouzid, okay? Huh? Anyway, let's use Sidi Bouzid because we have some good memories of it. So, Sidi Bouzid, you are in Sidi Bouzid and somebody is just near to you, 1 or 2 meters away from you. And you make a phone call to that guy, to your friend. Do you know how the communication goes? That voice communication comes all the way to gateways that you have here, probably in Tunis as a city, and then it goes back to it. So this has been okay for the low data rate applications or voice communications. Now, as we said, in 4G and 5G, you want to provide mobile internet. If you want to do that thing with the internet, it becomes very problematic. It's neither good for you as a user, as an operator, because you'll be having this gateways very much congested, and it's not good for the users because the quality of experience will also drop down. Okay, so that's why in standards and also lots of work has been happening in standards as well as maybe research as well. So they've been looking into how to decentralize the mobile core network by having, instead of having this very expensive gateway which handles like 1 million subscribers, which is centralized. By the way, even centralized in the architecture, there was a reason for it, because those gateways, they have to be in a very secure area with security, a building which is like earthquake resilient and so on. So, and to provide that kind of facility, somehow it was beneficial, or it was the best way to have it centralized. So there was a reason for that, but now it doesn't work. So they wanted to have small-scale gateways which are closer to the radio access network. So users will be serviced, or they will have their data and core gateway, the IP address will be allocated to them from very closer gateways. And also they want to look at what kind of traffic. If I see this is YouTube, Facebook, instead of using my scarce resources in the centralized core network, I just offload it. And even because quality of service is something which is very important for the operators, so they want to do that without the users realizing that their traffic has been deprioritized, has been offloaded to a third party. So that's why they want to build a mobile CDN, mobile content distribution network, which is very close, caches, and you can cache just certain type of videos, the popular ones. And then in this case, the chances of having users offloaded, their traffic offloaded and get taken from very nearby cache that you own and you can administrate, it becomes much more interesting. I think Adnan spoke about how we can build this mobile CDN on the cloud. That's even much more interesting when you can do it on the fly. Okay, still if you want to do this, you still have to buy these caches. If you do it in the traditional way, you have to buy this small service or cache. You have to buy these gateways, and this will increase your cost. And we get back to that question: will operators invest more, or is it the only way that I can deal with the problem by spending more money? So that was not in brief, I admit, about the mobile network. Now let's look at the cloud computing. I think Adnan has made my life easier by speaking about SDN, cloud, and NFV, so thank you very much. And that's why I will go very quick on cloud computing. It has many benefits. On demand, whenever I want something, I just get it. Self-service, so you can service yourself. Elasticity, which is very important. If I need more resources, I should not bother about that. I should not worry. Resources will be there. We don't want to throttle users. Like now, mobile operators, if they don't have much bandwidth, they don't have much resources, they'll just kill that application or that service. But it should not happen in 5G. Elasticity should be there. And why elasticity should be there? Because as we said earlier, 5G requirement is building a system which is almighty somehow for all the future applications. So if I have an application which will require just small amount of resources, still later if it needs more, it should come, it should happen. System has to be agile. So that means, like this agile approach of developing things. Whenever you need more, it should happen. Multi-tenancy, this is important. So I can have many tenants many users using my infrastructure. Pay as you go, so you will be charged only for what you have used. So these are actually the benefits of cloud computing, and there is nothing new here. I'm just telling you what cloud is offering, and later we'll come to the conclusion how we can benefit from these benefits or these advantages of cloud computing. So there are many business models. Adlan spoke about that, so that's why I'm not, infrastructure as a service, platform, SaaS, and so on. And it has this huge economical potential, reducing OpEx and CapEx. So it's basically what it does, it allows you to start small and grow in demand. Okay? And there are many cloud computing providers, because it's a very, fast-growing business. And there are many open sources. I think Adlan spoke about Zen, KVM, for different business models. So I will skip this. OpenStack, I'm very happy to hear that you have an OpenStack user group here in Tunis, and it's one of the sponsors, so that's very good to know. It's very good. So people working on cloud and so on, really OpenStack is the thing, but if you want to do it for telecom, OpenNV is the thing that you have to pay more attention to. Although they're trying to do the same thing, but of course taking into account the telecom perspectives. Now the thing which is very interesting about cloud, and which we want to use here, we want to exploit. If you go and you look in Google, you'll see their data centers being somewhere, they have very large data centers in the States, 3 big ones, I don't know, maybe one in Europe, and they don't have in China, and they don't have in Africa, and that's it. Okay? Amazon, the same thing. But now there is a trend towards having, and that's actually the talk which I attended of Microsoft, I spoke to you earlier about, that they want to have small-scale data centers distributed here and there. Why? Remember the mobile game thing I spoke to you about, the example? So I can, in order to achieve or to guarantee 30 milliseconds for the user, the only way is to place the data center and have the game hosted for him from very nearby. And that's why they want to have multiple small-scale regional data centers here and there. And even now, there is work ongoing where the data centers can be solar powered. You don't have to worry about the energy. There is a company in the States as well as in France that they have made a prototype of small-scale data centers that you can place in a parking lot. So you don't have to worry even about the location. Meaning you can rent a parking lot even in very expensive cities for 30 euros, 100 euros, and you place the data center and it will do the job. So that's the trend. I didn't spend too much time on cloud computing because good that Adlan covered that topic. But the only trend which I want to say is they are going towards this decentralizing, themselves. So, if we put everything together, we have cloud providers, because of the business which is growing, and because of demands on the services of cloud, low latency and so on, they want to distribute themselves. Now, if we look at the mobile operators, because they have this headache of too many devices, too much traffic and stuff, they also wanted to decentralize themselves and do offloading and so on. Up to here, any questions? So I can have my water. Okay, none, good. Then I continue. Now we get to the $1 billion question. And I don't think it's 1 billion, it's really multiple billions dollars question. I wish I had enough money so I could invest in this and maybe become a rich guy. But, we are just poor guys in academy. Anyway, the $1 billion question is, nowadays, cloud is limited to offer computing storage as a service. How many of you use Gmail? Oh, guys. Google is watching you guys. All right. How many of you know that, okay, what do you think? Gmail is a cloud service or not? Yes. It's a cloud service. Why it's a cloud service? It's a cloud service because it's easy, because you have your data stored in the cloud and the processing of your emails is happening also in the cloud. In order to enjoy this Gmail application, you still have to subscribe to mobile operator network. Right? You understand? To enjoy the service on your user equipment, you have to subscribe to Tunis Telecom. Now the idea is, we want to offer everything, as a cloud service. Think of even having that mobile connectivity, and I will explain to you how we can do that. That's why actually, this is something which will revolutionize the whole concept of mobile networking. Think of when you don't have to subscribe to Tunis Telecom, maybe you'll be having a provider of mobile service, which will offer you also the mobile connectivity, just by the phone, and the guy will make sure that you have the connectivity plus the service itself. Everything as a cloud service. And this will help, as we're trying to see, we have this issue of we want to decentralize the network, we want to reduce the cost, we want to deal with all of this too much traffic which are happening in 4G and which we expect in 5G. So this is going to come like a free lunch together. The interesting thing that many mobile operators, they also own their cloud infrastructure. Some of them, they use it for internet users, some of them, they sell it. How many of you know Telmark as a cloud provider? Telmark. Of course, you know Amazon, Rackspace, but Telmark is also a very big cloud provider. And that Telmark is owned by Verizon, which is the second largest operator in the state. So many operators own this stuff. NTT, for example, Docomo, they have NTT Data Communications, which is a huge cloud, even they operate in Europe. So there are many cloud offerings by major mobile operators. All of them do SaaS, IaaS, and all of them do PaaS or plan to do PaaS. I mean, those are the major operators. Okay. Oh, sorry. So now we get to the concept of carrier cloud vision. And before that, I'll speak about the NFV. I think, the job will be very easy because Adlan did a good job by telling you what's NFV. And I will go very quick on it. So as I said earlier, so far what we had this is offered by a vendor to an operator as one box. That means it does the job and it's built on a dedicated hardware which gives that 5.9 reliability. Now what we're going to do, we want to take the software, decouple it from the hardware and have it just like a piece of software that can run on any platform, virtualization platform, on any VM that you can instantiate on the virtualization platform. Guys, you remember in the network, in the EPS, we had PDM gateway, we had, can you please give me one name? Serving gateway, can you give me another one? MME, Mobility Management Entity. Very good. Now I can tell that you are following up with me. Very good. So basically what we can do, we can take that network function of the MME and put it on a virtual machine. And then what we have, you see it as an MME. You can do the same thing. You take a PDN gateway and you put it on the virtual machine, just the software, and you see it as a PDN gateway. The difference that instead of having it on a very dedicated hardware, it is working on a virtual machine. And this is very interesting because it will lead to what we call a new network production environment based on modern virtualization technology, which is still advancing and it will be progressing. But if you can see, this is actually copy and paste from the first white paper about NFV to lower the cost. Because the whole thing, the whole changes that are happening for one specific reason, which is economic. That means lower the cost, reduce the cost of investment, and raise efficiency and make the system agile. Because as I said earlier, the system has been built, new services emerge, and we don't know how to deal with that. We've been doing like short-term solutions. No, we want to have a system which can be agile. Whenever we face a challenge, the system can have, without short-term solution, without small tricks and tweaks here and there, the system can solve the problem by itself. There are many benefits of this NFV. I think many of them, I have spoken about them as well as Adnan spoke about them very in detail. One of them, which, scalability, multi-service, multi-tenancy, Adnan spoke about that. But there is this one, dynamic rollout of new network function services. This is, today I have a big concert, I expect like 1,000 visitors, I will build the network for 1,000 visitors. Tomorrow I have something else, I will put another service, okay? And this is dynamic rollout. One thing which is very interesting, increased speed of time to market. I attended one time a talk given by CEO of Portugal Telecom. It's quite big operator, at least they operate also in Brazil. And they said that actually the biggest competition happening between mobile operators, not in terms of getting subscribers, but in terms of reducing the time to market. Because many of them, they get actually customers. These customers, they come and they say, well, I want to provide this service. Tell me what you have, what you can build for me. So the operator, what he does, he goes and he sees what he has as resources, what kind of additional resources he'll be in need of. So he will make the order, then shipping will happen, then engineers will be deployed, and the whole operation is really taking, months, 4 to 6 months, in the best scenario, even to get the signature from the people and so on, from the seniors. Now, with this, with the open stack, with the concept of NAV, with the concept of SDN, this should be a matter of, I wouldn't exaggerate by saying seconds, but really by minutes. And this will increase speed of time to market. So that means if I have a service, I can make the assessment quickly and then build the infrastructure or build the visual infrastructure for that service very quickly. This is something which is very interesting. Support of diverse ecosystem and network opens. The successful story behind these phones or iPhone, it was not the phone itself. It was not the design which is good, The interesting thing about this in comparison to Nokia, and that's why actually Nokia did not do well, now they're trying to, take over, that these devices were built somehow, before they were like user equipment was somehow closed to operators telling the user equipment vendors how they should design the system, and it has to be closed. Nobody will put anything in it, only operators. Steve Jobs came and he opened this user equipment to developers. An API, put whatever application, put it on iTunes, and let people download it, and let the market judge whether that application or that service will be enjoyable or not. Now with this concept, you can do the same thing, because nowadays we have the network which is kind of closed. It's the business, the monopoly of operators. Now if I want to build a system, an application which is a mobile service, which requires mobile connectivity, then I can still have my service being stored in the cloud, like Gmail, like Facebook and so on, but still the connectivity itself, you do not need to depend on one single operator. I can provide you that, everything as one service. And I will show you how that can happen. Actually, Google being very much interested in this. Facebook is also very much interested in this. And that's why even Facebook did join, maybe 2 years back, GSMA, which is a standards body for only mobile operators. And people will say, like, why the hell Facebook is interested in this kind of, it's not their main business. Google also, they bought Motorola Mobility, and they sold it later to keep the IPRs of mobile networks, because they are interested in not being dependent on operators for the connectivity. Even, have you ever seen this project of Facebook and also Google of these big balloons? Have you seen that project? Yeah. So Facebook, they want to build a network probably which is going to cover the whole Earth with balloons, what they call unmanned airborne vehicles, like with routers, so they don't need even any mobile operator to provide them with connectivity to their servers. So if they achieve that, and I believe they will, maybe in 5 years, once they achieve that, the whole thing can be provided by Facebook. That means it will be the service, connection and so on, plus the connectivity to connect to that service, everything will be provided to you as one single atomic service, as we will see later by the cloud, by Facebook. And once you do that, this will encourage lots of innovation. Because nowadays, since Steve Jobs opened that user equipment to application developers, we started seeing a lot of interesting, some innovative as well as crazy applications. Now if you open also the network with NAV, with SDN, so you can control the things, the whole stuff becomes, it will be only your imagination that can be limited to what you can do with this stuff. So those actually were in addition to what Adnan spoke about as important, advantages of NAV. Now, to do this, it's lots of challenges they have been to deal with. High availability, because as I said earlier, reliability is a very important requirement. We cannot build the system, unreliable and say, well, sorry, just work with that. No, the system has to be reliable. Scalability has to happen even per VM, and the load balancing, it has to happen, because you'll be having different nodes serving different users, geographically distributed, and load balancing should happen. And even the infrastructure that you're using or you place your network function, that infrastructure will be shared by others. So you have to understand who is going to use what and do the load balancing even in advance. And I will show how we can do it. Performance is also a very important thing because latency and throughput, there is no compromise to make about that because those are actually requirements or regulations coming from the regulators. The system definitely will be very complex, but it has to be hidden from the user. And this is a matter of what and how to virtualize. So now, what to virtualize? You can virtualize the whole thing. That means the whole system, which I have explained to you, in the first presentation. You can build it as one single VM, as one single software, and you run it on in a virtual machine. So that means the whole control plane and the user data plane. Now, there are many operators that are not interested in this, or many, at least, stakeholders are not interested in this option because they know that the cloud computing is not advanced to that point that can deal with any problems at the user data. Because there is problem of resiliency, there is problem of, and cloud is very good at computing, very good at handling signal and traffic, and that's why they want to offload the control plane to cloud. But still the user data plane, they want to keep it on dedicated hardware because they are sure those dedicated hardware, they will work well, and they will have for you that 5 nanometer activity. Maybe when time allows, when these cloud virtualization platforms become too much advanced, and they can guarantee for you the 5-9 reliability, then you can make the whole thing, So as I said, you can put everything on the cloud, full virtualization, or you can put just the control plane on the cloud, and then you keep the user data plane on the, on dedicated. Now, how to virtualize things? This is really depends on what you want, and depends also on the network functions that you have in mind. There are different variants. And I'll explain each of them in brief. So for example, this is already, we have done it in the mobile cloud networking project. And actually you can do it also, there are some codes, network EPC that you can do that. So basically what you can do, you can take, you remember that architecture of the evolving packet system, you can take each network function and you place it on a virtual machine, separated, and then this is the easiest approach from the standards point of view. Because those software or those network functions, they will come with the interfaces that I have explained, like S1, S9, S7, those interfaces. So they will know each other and they will connect. They will interwork among themselves. The problem with this solution is scalability. Scaling up is very easy. Because when you want to scale up, you just instantiate a new VM and you put a new network function and that's it. Scaling down is a problem. And now the question to you guys, why it can be a problem scaling down? Anybody, can you make a guess? Yes, close, very close. Actually, he's, yeah? No, scaling up, as I said, it's very easy. Scaling down is a problem. He gave the hint, he gave the answer, but not the full answer. But it's close. The thing is, what happens here, this is the whole network, and all the VMs or all the network functions depend on each other. So if you have a network function, like say that you have a P gateway on VM1, and then now you want to get rid of it. This P gateway has some state information on which other nodes depend. Okay? So if you get rid of it, you have to make sure that the state information is not lost, that other nodes are dependent on. Otherwise, it becomes, it's doable, but it's much more complicated than one can. To solve this problem, that's why we have this concept of one-to-n mapping. One-to-n mapping, that means you take one network function, or one network function, and you place it on multiple virtual machines. So you will see it as a pool of VMs. Basically, so you have here a front end, and this front end is a load balancer, and then you have the logic, the logic of the network function, the process itself. You can, it's a worker. You can put it on VMs, and then you have the state information, which is somehow centralized on centralized on a database, which is also running on a VM. Now, if you want to scale up, you just add another worker here. If you want to scale down, you just get rid of the workers, and there is no impact on the state information. This is actually the basic concept that those large-scale applications developers adopt. So it is. We're just trying to use this in the context of mobile activity. Well, the advantage of this, as I said, scalability up and down, elasticity is very easy. But the problem is it becomes costly because one network function will be running on multiple VMs. So, and each VM will cost you some money, and also the management of those VMs. So there are issues, but as I said, you're not supposed to do the same thing for all the nodes. Maybe you can use this approach for the mobility management entity because it's supposed to handle many nodes, and you can use the concept of one-to-one for another network function because that's the most appropriate thing for it. What we have done, that actually you get all the network function and you place it on one single VM. So that means the whole mobile network, the whole EPC, you take it and you place it on one single VM. And this is also possible. Of course, use cases now, you may think like, why do I need it? But just think of having a core network which is personalized for you. That means it's the personalized core network for you, dedicated for you as a single user, or for a group of users that are sharing actually some features. And the thing, of course, there are advantages and disadvantages. The advantage, it is a very light EPC. Interfaces will be reduced. But the main disadvantage, that actually you will be locked into one single vendor or one single developer of this EPC. Because you cannot, because before, here, or even in the one-to-one mapping, I can buy this network function of MME from NEC, from NEC, because they are good at this, but I can buy another one from Ericsson because they are good. So I still can choose which one to buy based on the performance of each network function. But when you do it in this way, you cannot buy multiple subcomponents from here and there. It's going to be all together, and that's it. This is also another approach which is similar, but just you split. You can have the same, the whole network, the whole core network on two separated VMs. One is handling the control plane, and the other one is handling the user data. Okay, now we get to the concept. So as I said, we want to extend the concept of cloud computing beyond data centers towards mobile end users. So the whole thing will be provided to you as a cloud service. And this will come as one single atomic service, which comes with all of these nice features of cloud computing, on-demand elasticity, blah, blah, blah. So, I think, Asma, I have too many slides, but stop me whenever I have to. Okay, 5 more minutes and then we start. Okay, so now I will explain to you the vision of this carrier cloud in an animated way so you can understand the concept. All right? So, okay. May I have your attention, please? You remember, we have spoken about those giant data centers that will be supported by many distributed regional data centers. So that means we will see a cloud infrastructure, federated cloud, which is in this way. You have still those macro giant data centers, but you will be having also these regional data centers here and there. Maybe in the beginning you won't see them like, you will see them per city, but later maybe you will see them like every neighborhood has its own data center. Like nowadays you have this slum, which is in single neighborhood. You'll be seeing that, maybe not soon, but it will come. Now, we have this cloud resource controller, which is the brain, which is the one which knows what kind of infrastructure I have. By the way, this can be owned by the mobile operator, it can be owned by the cloud provider, or it can be a new business stakeholder. A new business stakeholder which is mediating between users and the infrastructure, and also running the logic of deciding where to place one. So here, as a user of the whole system, it can be a mobile service provider, and here a mobile service provider, it can be an enterprise, a mobile virtual network operator, as well as one single individual user. For example, you as a user, you want to develop an application, then you can become a customer of this user. You will tell your requirements. You tell your requirements to this cloud resource controller, okay? Say, for example, I want to have, as I said, like the example of concert. I mean, there are many examples, but let's stick to this. I mean, the example of concert. I have maybe 1,000 visitors to that concert, and I want to build a core network for them. So I will just tell the cloud resource controller, please build for me a network in that location, okay, for 1,000 subscribers. And if more come, then you will ask for more resources, and if less come, then you will still tell him release resources, just do this for me. Okay, now the cloud resource controller gets the requirements of the user, knows what he has as an infrastructure, and here he will run a logic, and this is the planning. And this planning will take into account, I mean, of course I'm simplifying things, but I can share with you later papers that I have written with Adnan on the topic. Then the cloud resource controller will decide where I'm going to put these network functions. Shall I put them here? Shall I put them there? How I can reduce lots of things which are actually relevant to the mobile operating network. Reducing the serving gateway relocation, lots of things. Then, you know, this is a configuration. Up to here, it's just a configuration. Nothing is deployed yet. So then this is communicated through like a dedicated API, an application interface, via, say, OpenStack or OpenNAV. And then what happens, that this OpenStack will say, give me VM with this characteristic, place on it this network functions for the user number 1, for user number 2, for user number 3, for user number 4, and so on and so forth. And now, these network functions, they can be anything. They can be even this video cache. Actually, if you do the video cache, if you put in here and there video caches as software on VMs that you specify, you know what you're building? Do you know what you're building? Adnan spoke about it. Actually, you're building a mobile CDN. You're building a mobile content distribution network on the fly, on the cloud. Okay? And it's up to you to decide what kind of videos you want to store there. Now, how this is happening, I will explain, because here we're trying to marry between two domains that have been working separately. Cloud providers, or IT, cloud computing guys, and the mobile telecom. And each of them speak different language that, you know, they will not be able to communicate unless you find a way to translate that communication. All right, so now what happens is, this is the same, mobile service provider tells the cloud resource controller, these are my requirements, and then the guy will say, I have to place for you this and that. Taking into account your requirements, taking into account the underlying infrastructure, taking also into account the users that are using the system itself. Because this is a system, multi-tenant system for many people, and this is really the challenging thing. You have to see what, I mean, who is using what, and you forecast, and then you have to build a system for this guy. You cannot tell him, okay, now I'll give you these resources and later I'll take them out from you. Now, up to here, this is the language of the mobile telecom. So that means I will say, give me one database in location 1, give me one P gateway in location 1, give me 2 serving gateways in location 2 and 3, give me one mobility management entity in location 1, give me 2 eNode Bs if you want to do the radio access network in these locations. You know, up to here, this is the language of telecom. If I say this to Amazon controller, the Amazon controller will not understand. Okay? And that's why we need to translate this into the language of cloud providers. So basically what you say to the cloud provider, to OpenStack, you can say, give me 3 VMs in location 1, give me 2 VMs here, and build a network for me. Link everything together. So you're building for me a virtual network infrastructure. Of course, you can specify more. You can say what CPU, the storage, the memory, and so on. You can specify in the VM, and there are actually flavors in OpenStack that you can choose. You can specify, the kind of VM that you want for each network function. Up to here, you say to Amazon controller, okay, now these are my requirements. Get me the stuff. What happens? You get the VMs here and there. And now it's up to you. It can be the cloud provider, Amazon, they have images of these network functions, or you can install on them whatever, or you can have Ubuntu and then you put on them any existing open source for any network function. So basically you put the database here, you put the software, PDM gateway here, and put in here soft, that means it's a network function, MME, and here and there. So you have placed the stuff together here and there. If you do this following the standards, what you have done, you have built a network which is end-to-end, all over the cloud. So you have built, the database is on the cloud, you have built the core network on the cloud, you have built also the radio access network on the cloud, everything will be interfaced following the standards, and you have the whole service end-to-end provided to you on the cloud. This, for example, you can do it for, as I said, I'm using the same example, concept of 1,000 subscribers, but then visitors, and then you realize that actually not 1,000 people, or the people that you have, that you were expecting in location 1 did not show up, then you can just dismiss resources there, do the same thing, and then you will build another network which is in another location. And this is how the system becomes agile and dynamic and so on and so on. So you can do whatever you want, a programmable virtual mobile network, which is carrier grade. And this is actually the topic of today's presentation. All right, so I will skip this. Of course, if you do it in the way that I have mentioned, you can achieve this distribution of the gateway. You can decentralize the mobile network in a very cheap way, and you can have always this optimal connectivity. All right, but still, if I use this system and I have the gateway, for example, which is optimal for me here in Tunis, but still my service is in Finland, it doesn't make sense. And that's why we get to the concept of Follow Me Cloud. Follow Me Cloud, we have implemented this. It's working with OpenFlow. Adler also and his team, together we have actually implemented this on the, using Lisp, everything on the cloud. I'm not going to get into details about that for the sake of time. So anyway, FMC is not only the content which is following you, it's the service which is moving with you as close as possible, as fast as possible, and at the most affordable cost. I don't want the service to follow me if I'm going to use it just to watch the last 5 minutes of a video of 2 hours. Because moving things will cost money. The system has to understand when it has to migrate and when it does not have to migrate. So you have here, like for example, I'm having here optimal connection. I move to Tunis, I get like service here, but then some part of my service will follow me, and then the service, I will be receiving it from the data center which is here. And there are thousands of use cases for this. Lots of challenges. I'm not gonna, I will share this with you guys. But one thing which is very interesting, I think one of the questions was asked is scalability. Because when you do this, every user has multiple services, and even a service can consist of multiple flows. Okay? If you have something which is streaming, you have RTP plus RTCP, and each of them, they are actually different flows. How you can do the management rules, how you can define management rules for these users that are moving, like this is the case of Japan, and this is the case of Pakistan. I hope that these guys will not use their mobile phones, otherwise no guarantee for their life. Okay? All right, I think I will skip this. There are thousands of use cases. As I said, I wanted to speak about how we can alleviate congestion, how we can manage congestion using cloud. There are thousands of ways to do this, with cloud. But for the sake of time, I will not handle that because I think there is no time. But one single use case, and I'll stop my presentation. One single use case. Nowadays, I don't know about Tunis, but there are many users, many utility providers in Europe as well as in Japan, I think in the state. In the state, I saw it with my own eyes. Actually, they have the service that they have, the electricity or water consumption. They have sensor that measures this and then send it to the server via mobile network. That's NTC. Okay. In Japan, I recall 3 years back, they were charging for one single MTC. MTC, as I said, it's a sensor with a SIM card, okay? For that subscription, they were charging almost 7 euros per month. Now, a utility provider, let's do the math, because everything is just about economy. A utility provider that will collect the measurements, of electricity consumption. How many electricity meters here in Tunis? I don't know. It should be a huge number. Okay, millions. I mean, the whole country. Now, if I have to pay 7 euros per device, or even I can make a negotiation with the operator and make 3 euros, as discount per device, and that device will take for me a measurement and send it at the end of the month, or probably at the end of every month, or at the end of 3 months, it depends on the country. In Germany, for example, they send you the electricity consumption at the end of the year, so it's only once a year. And I have to pay 3 euros for a million of devices that have to connect to the network every month. This is a huge amount of money. With the idea of NFV, SDN, MCN, mobile cloud networking, I can build a network at the end of the month, for example, towards the last 2 hours of the month, or of 2 months, and I build the network so I can collect data from the MTC devices and send it to the MTC server. Measurements are collected, usage of the resources happened in 2 hours. I pay only the 2 hours resource usage of the cloud. Of course, it will be much less than 3 million euros every month or every 2 other months. And I will dismiss the resources, and I'm charged only for what I have consumed. This comes with lots of interesting things: configuration flexibility, short time to market, and significant cost saving. Okay, there are lots of uses. Question is, can we do it? Yes, we can. Quoting Obama here. If we join efforts and expertise from these 3 areas, software engineering, telecom, cloud, we can do it, because we have already the technologies that Adnan, for example, highlighted, SDN, NFV. Direction is going towards that direction. And yeah, if it is done, it's just a matter of putting everything together in a system which is meaningful, which meets the requirements, and which is smart and so on. So, to conclude, I have spoken about the operator's dilemma. As I said, it's more economical than technological, because they have this problem of average revenue per user. Mobile cloud networking offers many advantages. They can exploit NFV, SDN, and so on. But there are many challenges for realizing this concept. And this is good news for us, at least for me, because it will justify my salary for the next 5 years. Thank you very much, guys. Now, any questions, or we can have the coffee break? I think no question, because everything was understood. Now there is one.
Thank you for your presentation. To have distributed cloud with mitigation
I am very sorry, because I really cannot hear you, because there is noise around here. So if you can raise up your voice a bit.
to build distributed cloud with many regional data center, how we can we ensure interoperability, or we must buy from one vendor?
Fair enough. This is, I mean,
standardization.
yeah. Yeah, this is actually what they call federated cloud, okay? So the federated cloud can be the easiest approach when you have a data centers belonging to the same cloud provider, that's it. But still, you can use the same infrastructure coming from different cloud providers. And there is a new business appearing there, which they call cloud brokerage. That means there are some cloud broker guys, companies, which will provide you with the platform which is coming from different data centers belonging or administrated by different cloud, but you as a user, you see it only as one single platform which is provided. It's challenging in terms of quality of service and so on, but it's doable, and the trend is going towards that direction. They don't want to be locked in into only one single cloud, which is Amazon or Rackspace and so on.
No, about an operator want to build a distributed cloud, a mobile operator, for example, should he buy data centers from one vendor, or there is normally standardization and he can buy from many vendors for Cloud, for dynamic virtual machines?
I think, I don't know, but I don't know, it's up to the operator. You can buy from different vendors or from the same vendor. You can even buy from the same vendor and later on you can buy from a different vendor, so you end up by having a cloud which is consisting of data centers belonging to HP and the other one belonging to IBM. I don't see any problem there if you configure the data centers in a way that you see the holding as like one single data center. Adnan, or do you have any, you work on CDN or cloud? You want to answer this question? You have any?
Yeah, what I wanted to say that for CDN, what I wanted to say is that for CDN, there was a video delivery service providers. They use several CDNs. They call it multi-CDN infrastructure. So they are able to switch from one CDN to another. Some CDNs are people in some areas, other areas. So probably it could be the same for the cloud. Some cloud providers, typically OVH is in Europe, Amazon is in the US, so you can switch from one to another. It's not
I think I really don't recall the name of the service, but there are many. I think one called Max CDN. It's a Foxy thing. And this Max CDN, they will, I mean, you put your requirements and they can even tell you, for example, we'll get you CDN from Europe from this particular CDN provider, and the other one from Latin America. And, you know, they can tell you even how much the price. So you can, I mean, there are many websites of CDN providers as well as cloud providers which will tell you we can get you this and this at this price. So if you subscribe with us, we will provide you with this thing at this reduced price rather than dealing with the cloud providers or with the CDN providers. And I think it's already happening. People, when they use, I think even in NEC we had a small data center. It was consisting of IBM servers, and HP servers, Dell servers. Yeah, it doesn't matter.
Thank you. Just, it's true that currently some service providers like Netflix are paying charges to some telecom operators for the overall traffic. Because I heard that in news.
Yeah, it's been always this fight between between service providers and operators. Because so far the operators, they've been giving free ride to these service providers, and these service providers, they've been making money out of advertisement and, you know, having the whole cake. So that was, I mean, at least many operators were not happy about it. And that's why operators, they started saying, okay, instead, even those service providers, they're not using their infrastructure. They're using, for example, Akamai. Okay? And they pay money to Akamai, and Akamai just delivers the stuff. And the operators, they give, you know, they deliver the content to the users. Now, the concept of mobile CDN, mobile content distribution network, that the operators that are not happy with this, or they could not get anything, maybe with Netflix, they had some deal with AT&T or Verizon, so they could reach that agreement. But many mobile operators wanted to reach similar agreements with others, but they could not. Now, these guys, what they want to do, they want to build their own mobile CDN. So they become like an Akamai, And they will go to these Google providers or Netflix, they will tell them, look, instead of putting your data in Akamai, you can put it in my mobile CDN, and I will charge you the same amount of money or less, that Akamai was charging. So they want somehow to get into the business of Akamai and also make some money. I know the only mobile operator, as far as I know, that could have a very good deal with Google in terms of sharing something out of the revenues from the advertisement was Orange. And I heard this from a senior guy in Orange. The reason for which,
It's confidential.
No, it's not confidential. Well, he told me. Then he told me it doesn't become confidential.
But it's confidential.
No, well, I don't know. I mean, I've said this everywhere, so I don't care. I don't work for Orange, so they cannot fire me, they cannot do anything to me. And they don't fund me. So, anyway, so what the guy said, he said that actually Orange in Europe, they're not doing very well in terms of business, because they are somehow, at least 2 years back, they were in minus. But they forced Google to provide them with some share on their advertisement. It was even on the news, because they had a deal with Google. He said, okay, if you want to deliver your content with some kind of quality of service and so on in Africa, because Orange has a big actually presence in terms of infrastructure here. I think even in Tunis you have it, in Ivory Coast, in many other countries. So in order to facilitate the delivery of your content, we have to make this deal. And actually Google accepted it because it was like a win-win strategy. Maybe you want to add something? Yeah.
Just a question.
A question to me?
Can I?
You can.
It's because I think Fox. What do you think of 6Fox on this kind of long-range network for
6Fox?
6Fox.
I don't know.
Lahouar, the long-range networks for the sensors.
This wave and stuff?
Yeah.
As I said, like I showed in one slide, which I borrowed from Ericsson, it's going to be one technology which will be used in 5G, but it's not the only technology. I think.
Yeah, just to explain, it's for the sensors for metering. They say that they can they develop wireless networks with very low performances in terms of bandwidth, but very high range, very long ranges, like kilometers. And so everybody is supposed to send a few bits of data every hour, like sensors, or every 5 minutes. But so how can it be integrated into 5G?
Well, as I said, 5G will be consisting of different access technologies. HEPNet will be something which is, I mean, Wi-Fi will play a very big role, I believe, because basically most of the communication happens in places that where there are many people around. Okay? Even when you surf the internet, it happens either at a train station and in the mall and so on. So that means in places where you can play, where you can put Wi-Fi networks. So they think of using Wi-Fi for providing, services, mobile services, and Wi-Fi, as if you remember, it's treated as a non-3GPP trusted network. So that's actually the reason why they put it as trusted, because it becomes then less costly to connect to the network. This wave is also, many people are actually speaking about it, but I am not really expert in that. I've attended also a talk that was given by a senior from China Mobile. They put lots of, they have lots of interest. Of course, the wave, when you make it very small, and it's, of course, it's very powerful, but then you have lots of issues with interference. People are working on it. Now, I recall here an application that, for example, since you're speaking about sensors, many people were thinking that Zigbee will do the job by having many sensors involved into the communication. But then they realized it's not really as good as they were expecting. And now why they were thinking about Zigbee? Because Wi-Fi, because of the MAC protocol of Wi-Fi, was not very good for sensors to connect to, because there are lots of signal messages which will, eat the bandwidth. Now, IEEE 802.11, they have realized the problem, and that's why they have a new variant. I can't remember what. It's not HCD. Huh? Yeah, NH. Yeah. So NH is actually designed specifically to deal, because one Wi-Fi access can maybe 100 meters square, more than 100 meters square that they can cover. And in that case, they can connect to sensors without even draining up their energy. And this was even, actually there was like this company called, of Misha Dura, if you know him. So he tried to deploy a smart parking in Moscow, and the issue that he realized, or he found, that actually in Moscow they don't have this electricity, spots. Yeah, the pods. And because of that, they could not even put these ZigBee readers or whatever. And that's why they had to put, they had to go for Wi-Fi, because it was the only thing, and they had to decide where to place it, because at least instead of putting many, the ZigBee readers or whatever, or sinks, at least you'll be having only one Wi-Fi which will do the job, and still you don't have to, consume too much energy of the sensors, so you don't have to change the battery. So, to answer your question, and as I said, 5G, nobody knows what it's going to look like, but I think many people, even from companies, at least the talks that I have attended, they say it's going to be a bunch of technologies from here and there, 5G, this MN wave, there is this, of course, Wi-Fi, and there is massive MIMO, and there is this new technology that they call, not OFDMA, but something else, which they are. But as I said, it's actually, these are the aspects on the radio access network. Now what I try to deliver as a message, there is also a very big change that will happen on the core network, because everything can be provided on the cloud, and that's why many things are happening, in parallel, the radio access network, and also.
Any other questions? So thank you, Mr. Tarek Taleb.
Maybe you want to ask a question? You want to ask a question? No? Okay.
Thank you so much, Mr. Tarek.